Hello everyone, welcome to new class. Today I am going to discuss about the problems related to electromagnetic induction. Let us go through the first problem. A coil is wound with 220 turns and has a resistance of 50 ohm. If existing voltage is 200 volt and magnetic flux is 0.08 Weber, calculate the self-inductance of the coil. First of all, write down the given datas. Number of turns, flux, resistance and voltage is given. We have to find the self-inductance. And we know self-inductance L is equal to N into 5 divided by I. But the current is not given. First find the current. I is equal to V by R and we get 4 ampere. Now substitute the values in the inductance equation. We get inductance as 4.4 Henry. Next problem. A straight conductor of length 2 meter moves at right angle to a uniform magnetic field of flux density 2 Weber per meter square with a uniform velocity of 40 meter per second. Calculate the induced EMF in the conductor. Find the value of induced EMF when the conductor moves at an angle of 45 degree with the direction of the field. From the question, we know that the conductor is moving and the magnetic field is stationary. And this is the case of dynamically induced EMF. And the dynamically induced EMF is given by BLV sin theta. In the first case, the conductor is at right angle to the magnetic field. So, the theta will be 90 degree and sin 90 is 1. So, we get dynamically induced EMF is equal to BLV. All the datas are given and we get 160 volt. And in the next question, the conductor moves at an angle of 45 degree with the direction of the field. That is theta is 45 degree. Then the dynamically induced EMF is equal to BLV sin 45. And we get 113.12 volt. Let us go through the next problem. A coil of 200 turns carries a current of 4 ampere. The magnetic flux linkage with the coil is 0.02 Weber. Calculate the inductance of the coil. If the current is uniformly reversed in 0.02 second, calculate the self-induced EMF in the coil. First, write down the given datas. The first question is to find the inductance of the coil, that is L is equal to N5 by I. All the datas are given and we get the inductance as 1 Henry. The unit is very important in all the problems. And in the second question, the current is reversed in 0.02 second. So first find the change in current, that is di equal to I1 minus I2, that is 4 minus minus 4 equal to 8 ampere, and the value of induced EMF is, that is magnitude of induced EMF is equal to L into di by dt. L is 1 Henry, di is 8 ampere, dt, that is dt is given as 0.02 and we get 400 volt. If we write magnitude of E, then no need to write the negative sign here. Let us do another problem. This is very important problem. Two identical coils P and S, each having 500 turns, lie in parallel planes. Current in coil P, changing at the rate of 500 ampere per second, induces EMF of 12 volt in coil S. Calculate the mutual inductance between the two coils. If the self-inductance of each coil is 50 millihenry, calculate the flux produced in coil P per ampere of current and coefficient of coupling between the two coils. First of all, write down the given data. Here, two identical coils P and S, that is primary and secondary. So, identical coils each having number of turns as 500, that is N1 equal to N2 equal to N equal to 500, and also the rate of change of current is given, that is dI1 by dt 500 ampere per second, and induces EMF of 12 volt in coil S, that is E2 is given as 12 volt. Also, the self-inductance of each coil is 50 millihenry. That is L1 equal to L2 equal to L equal to 50 into 10 raised to minus 3 Henry. First question is find the mutual inductance between the two coils. The relationship between mutual inductance and the induced EMF is given as E2 is equal to M into dI1 by dt. From this we get mutual inductance M equal to E2 by dI1 by dt, that is 0.024 Henry. Next question is calculate the flux produced per ampere. For that we have L1 equal to N151 by I1. So the question is find the flux per ampere, that is 51 by I1 equal to L1 by N1. All the datas are given, that is L1 is given as 50 into 10 raised to minus 3 divided by N1 500, and we get 1 into 10 raised to minus 4 Weber per ampere. The last question is find the coefficient of coupling between the two coils, and we have coefficient of coupling K equal to M divided by root of L1 L2. M is 0.024 divided by L1 and L2 are equal. So, root of 50 into 10 raised to minus 3 into 50 into 10 raised to minus 3. And we get 0.48 or 48%. Next problem. An air-cored toroidal coil has 450 turns and a mean diameter of 30 cm and a cross-sectional area of 3 cm square. Calculate the inductance of the coil, the average EMF induced if a current of 2 ampere is reversed in 0.04 second. First of all, write down the given datas and convert into SI unit, that is N is given, that is number of turns 450, diameter 30 cm, that is 0.3 meter, area of cross section 3 cm square, 3 into 10 raised to minus 4 meter square. The question is find the inductance of the coil. We have L is equal to N square by S, where S is the reluctance of the coil and S is L by mu 0 mu r into A. The value of mu 0 is 4 pi into 10 raised to minus 7, and the relative permeability of air is 1. And here we have to find the length. The length is nothing but the circumference, that is 2 pi r, or we can write pi into d, that is 0.3 into pi. Substitute all the values. We get reluctance as 25 into 10 raised to 8 ampere turns per Weber. Now find the value of inductance, n square by s. We get 8.1 into 10 raised to minus 5 Henry. Next question is find the average EMF induced if the current is reversed in 0.04 second. That is induced EMF is equal to L into di by dt. L is 8.1 into 10 raised to minus 5. di, that is the change in current, is 2 ampere minus 2. So we get 4 divided by dt is 0.04. And we get 8.1 into 10 raised to minus 3 volt. Thank you for watching the video. If you like the video, please like, share and subscribe my channel.